So welcome back, ladies and gentlemen. We're going to actually look at one of the examples from your textbook found on page 308, example 4. And again, you might want to pause the video. I decided to do this question maybe slightly different than what's posted. I actually don't know what the answer is on example 4, page 308. So we have tan phi is equal to sine phi plus sine squared phi all over cos phi times 1 plus sine phi. Now, it takes a little hard to pronounce. So it's okay to do a quick substitution for the angle phi with x, or theta if you wanted. So I just rewrote the question. Now, I obviously chose the more challenging side, which was the right-hand side. And in this example, I noticed to actually factor out a GCF out of the numerator. I didn't do anything in the denominator. I did not expand that. I left it. Though sometimes you might have to do that. And we have some hints over here. And if you want to pause the video, feel free to look at them. But I'll explain these in a moment as a strategy after we finish this. And then once we actually factored out the GCF, we actually noticed that we can divide out the 1 plus sine x over the 1 plus sine x, because they divide out. And what we're left with is sine x over cos x. Using our identity of sine x over cos x, which really is tan x, and then replacing it back to the original question. Notice we have actually already proven that this left-handed side definitely equals this right-handed side. Again, one more time, this is true, but most students will never memorize this. No one does this. Okay, but now it's true. And so that is the format. As the tips, really, really quickly, it's in blue, and I apologize if you're watching from home. The tips are change everything in terms of sine and cosine, work with the more complicated side. You have to kind of remember what fractions are, so maybe how to multiply or divide fractions, or how to add or subtract fractions. And again, some algebra skills of expanding, factoring, difference of squares, perfect squares, even conjugates might help you. And finally, the Pythagorean identities are very, very useful to solving questions. Okay? So that was example 4 from your textbook.